In this section, we're going to look at how we can use reduction half-cell values in order to design a spontaneous cell. In this problem, you need to figure out what would be the oxidation and what would be the reduction to make a spontaneous battery. Again, you always have to have one reduction and one oxidation, so figure out which half-cell is better for each job. And then after you find the overall voltage, also go ahead and balance the chemical reaction. Okay, so aluminum is a bad reduction. So obviously it's going to be a better oxidation. So if we flip this, we have an aluminum oxidation half cell of 1.66 volts. So 1.66 plus 0.34 gives us a 2 volt battery. Copper is a 2 electron process. Aluminum is a 3 electron process. The best way to balance these reactions is that 6 electrons transfer to both sides, which means 3 coppers and 2 aluminums to balance the reaction. Okay, go ahead and try this one. Same basic idea. All right, so in this one, the iron is the worst reduction, so it'll be our better oxidation. So I'm going to flip that one to give us a positive 0.440 volt oxidation. And then balancing these chemical equations, they will both be balanced with 2 electrons, so 2 coppers reacting for every 1 iron, and a total voltage of 0.961 volts. In this one, we've got to find one reduction and one oxidation to get a total battery voltage of more than 1 volt. Now, the way I typically choose to solve this problem is just by going for the highest possible voltage. But there are 2 possible answers here, one that gives you just above 1 volt and one that gives you like 1.2. I went for the 1.2, but either of those answers would be fine. So our highest reduction is going to be the single electron copper reduction. The highest oxidation is going to be the worst reduction, so that's the chromium. It's negative 0.74 volts as a reduction, but if we flip it to an oxidation, it gives us positive 0.74 volts. 0.521 plus positive 0.74 volts gives us a total voltage of 1.26 or 1.261 volts for the E cell. Now, the other way you can make this spontaneous is by using the copper plus 2 voltaic cell, which is 0.337 volts. That will give you just about 1. I think it's something like 1.07 volts, 1.08, something like that. All right, so usually when I have a lab, this is the kind of lab I like to do, we can measure the voltage of the entire voltaic cell. And if we know what one of the half cells are, we can figure out what the other one is. So we have a chromium to chromium 3 plus anode. Therefore, what reaction is occurring at the cathode? So figure that out and work backwards to figure out the cathode reaction. All right, so when we say anode, by definition, we mean oxidation, right? Vowel, vowel. You could also get the hint by looking at chromium changing to chromium plus 3. It is a clear oxidation. So if we look at chromium, it's a negative 0.74 reduction, which means it must be a positive 0.74 oxidation. Our E cell was 0.46, so the difference is negative 0.28. That negative 0.28 means it has to be a cobalt reduction.